Hey everyone, welcome, and this video is going to be a pretty simple video. It's a pretty simple concept, just has a complicated name, I guess. So we'll be introducing you to the concept of transpose of a matrix. Um, right now, the information that you know about matrices, you don't probably need a transpose, um, or to know what a transpose is, but it will become a lot clearer and a lot more helpful once you expand on your matrix knowledge. So basically, what is a transpose, right? So before I tell you what a transpose is, let's say I have some matrix A, right? And I don't know, it's just I'm just gonna say it has elements A, B, C, D, E, F, G, H, and I. Okay, so these are elements of a matrix. The dimensions of this are 3 by 3. Now, sometimes you'll see notation, some sort of like A, I, J, right? What this basically means is what's the element in the ijth section of the matrix. So basically, I is denoted by the rows, so how many rows there are, and j is the number of columns. Okay, so if I say a 2 1, right, 2 comma 1, all right, what element am I referring to? So you basically go down to the second row of the A matrix and then over to the first column. So this is the first row, second row, and then the first column in that row. So it'll be D. So A2 comma 1 is equal to D. That's the element. Now if I say what is A3 comma 2, right? You're going to go down to the third row, so 1, 2, and 3, which is this one over here, and then on to the second column. So this is the first one, this is the second one, so that's H, right? So that's pretty much it. I wanted to introduce you to this because, like, formal definition for a transpose, I'm not going to prove it or anything like that, but basically it is AIJ, right? And then we denote it by transpose, right? So that's like it's like a t on the exponent, okay? So that is equal to a ji, okay? So what this basically tells us to do is take the aij element in the matrix A, right? And make it so that in this new matrix, a transpose matrix, that element is a ji element, okay? And you do that for every element. But there's obviously a super simple way of actually figuring out the transpose, and that's basically what I'm going to do right now. So in this example, let's say I have some matrix A, right? And it is 1 0 0 0 1 0 2 1 5000. Okay, I don't know. I'm getting tired of these small numbers. So it looks like a 6. It doesn't matter, but whatever. I'm just gonna call it 6,000, whatever, instead of 5,000. Okay, so how do I figure out the transpose of this? Which is denoted by a t. Now this is an a to the power of t. In matrix exponentiation, I don't think it's too relevant. Um, at least not now. I mean, it is relevant, but we're not going to cover a lot of matrix exponentiation, right? So this isn't a to the power of t, it's just a transpose. You can think of this as like a superscript. So how do you do that? The easiest way to think about it is the first row of the original matrix, the A, becomes my first column, the second row becomes my second column, and the third row becomes my third column, right? So that's how I think about it. So basically, here's what happens: the 1 0 0 becomes the first column, 1 0 0. The 0 1 0 becomes the second column, 0 1 0. Right? And 2 1 6000 becomes my third column, so 2 1 6000. Right? Now, there's another way you can do that, right? Since you're basically just reversing columns and rows, you can also think about it as, let's see a different color over here. What I can do is my first column becomes my first row, right? I can do that. So it'll be 1 0 2, I can do my second column becomes my second row, so 0, 1, 1, and then my third column becomes my third row, so 0, 0, 6,000. All right. I mean, it's up to you. It's your personal preference which one you want to reverse. It doesn't matter because as you can see, these two matrices are exactly the same. And one way you can check if you did it right is uh, if the first element, which is the 1 over here, and the last element, which is a 6,000 over here, right? They have to be exactly the same. Okay, transpose will not change them up. Okay, and also it's becoming really a colorful mess over here, but um, I don't know, the 0 over here and then the 2 over here are flipped. Okay, so in this case, yeah, it worked out nicely. The inertial matrix was the 3 by 3 dimension. A transpose was also 3 by 3, but let's do another example to make it more clear. Okay, so if this is the case, then what is A transpose? So what is A transpose? Is equal to 170, right? Now the 280, second row becomes my second column, 280. Third row becomes my third column, 390. 410, 511, and then 612, 15. Right? So you can see that the dimension for my original matrix was what? 1, 2, 3, 4, 5, 6. 6 rows. How many columns? 1, 2, 3. So it was 6 by 3. The A transpose, what's the dimension of that? 1, 2, 3 by how many rows? How many columns? 1, 2, 3, 4, 5, 6. Right? So yeah, just an n by m matrix, transpose of that is equal to, I don't know, just A transpose will have dimensions of n by n. Okay? And again, you can just check the 1 over here is still the same, the 15 over here is still the bottom right element, and the top um, left element stay the same. And then the 6 over here is 6 over here, so they got switched. 0 is here, 0 is here. Okay, so that's pretty much it for this video. Hope you liked it and learned a lot. And good luck, and I'll see you in the next one.